For my video project, I'm going to talk about the 4 forces of flight that act on an aircraft in flight. 4 forces in flight. Now, first, before I go into what those forces are, I'm going to define what a force is. A force may be thought of as a push or pull in a specific direction. A force is a vector quantity, so a force has both magnitude and direction. When describing forces, we have to specify both the magnitude and direction. The first force I'm going to talk about is the force of weight. Weight is a force that is always directed toward the center of the Earth. The magnitude of weight depends on the mass of all airplane parts plus the amount of fuel plus any payload on board, for example, people, baggage, freight, etc., things of that nature. The weight is distributed throughout the airplane, but we can often think of it as collected and acting through a single point called the center of gravity. In flight, the airplane rotates about the center of gravity. Flying encompasses 2 major problems: overcoming the weight of an object by some opposing force and controlling the object in flight. Both of these problems are related to the object's weights and the location of the center of gravity. During a flight, an airplane's weight constantly changes as the aircraft consumes fuel. The distribution of the weight and the center of gravity also changes, so the pilot must constantly adjust the controls to keep the airplane balanced or trimmed in flight. The opposite force from weight is the force of lift. To overcome the weight force, airplanes generate an opposing force called lift. Lift is generated by the motion of the airplane through the air and is an aerodynamic force. Aero stands for air and dynamic means motion. Lift is directed perpendicular to the flight direction. The magnitude of the lift depends on several factors, including the shape, size, and velocity of the aircraft. As with weight, each part of the aircraft contributes to the aircraft lift force. Most of the lift is generated by the wings. Aircraft lift acts through a single point called the center of pressure. The center of pressure is defined just like the center of gravity, but using pressure distribution around the body instead of the weight distribution. The distribution of lift around the aircraft is important for solving the control problem. Aerodynamic surfaces are used to control the aircraft in roll, pitch, and yaw motions. The third force I'm going to talk about is the force of drag. Drag. As the airplane moves through the air, there's an aerodynamic force present. The air resists the motion of the aircraft, and the resistance force is called drag. Drag is directed along and opposed to the flight direction. Like lift, there are many factors that affect the magnitude of the drag force, including the shape of the aircraft, the stickiness of the air, and the velocity of the aircraft. Like lift, we collect all the individual components, drags combines them into a single aircraft drag magnitude. And like lift, drag acts through the aircraft's center of pressure. The fourth force I'm going to talk about and describe is the force of thrust. To overcome drag, airplanes use a propulsion system to generate a force called thrust. The direction of the thrust force depends on how the engines are attached to the aircraft. 2 turbine engines are located under the wings parallel to the body with thrust acting along the body centerline. On some aircraft, such as the Harrier, the thrust direction can be varied to help the airplane take off in a very short distance. The magnitude of thrust depends on many factors associated with the propulsion system, including the type of engine, the number of engines, and the throttle setting. The motion of the airplane through the air depends on the relative strength and direction of the forces. If the forces are balanced, the aircraft cruises at a constant velocity, which we call straight and level flight. If the forces are unbalanced, the aircraft accelerates in the direction of the largest force. So as the drag force increases, the thrust, the opposite force, decreases. Same with the lift force. If lift were to increase, the weight would inherently decrease. And those are the four forces of flight acting on an aircraft in flight.